Are we good?
Good morning, everyone. How's everyone doing today? Wait, that wasn't loud enough. Good morning. Welcome, everyone, to TechBash. If you're not aware, we are streaming this live on the Visual Studio Twitch channel. So if you have friends back at home, be sure to tweet, send a message, let them know that, hey, we are streaming live. To all of you that are watching us live right now, thank you very much. This morning, our keynote has flown in directly from Microsoft. He's the director of program management for .NET, basically meaning he's in charge of everything .NET. So he is going to be here on stage and has joined me. Welcome, Scott. This is Scott Hunter, everyone. And he's going to tell us a lot about where .NET has been and where it's going. So welcome very much.
Thank you. So as you said, I'm Scott, one of the many Scotts at Microsoft on .NET. I've been working at Microsoft for 11 years. I joined the ASP.NET team back in 2007, along with Scott Hanselman back in the day. And now all of .NET's in the same group together, so we're very happy about that. And I thought I'd talk about what could have happened with .NET, because a lot of folks don't know the real history of .NET. And that this is streaming, I'm probably going to get in trouble for this, but I should not actually be doing .NET. I should be building Java tools. We actually had a product called Visual J++ in 1997. But in typical Microsoft style, it was Java, but it was not. You know, we added our own flair to Java. They had a method for actually calling native code, which wasn't very good. So we didn't put it in there. And then we added our own features, JDirect, that's the equivalent of pinvoke. And we added callbacks and delegates, which are two of the features that you have in C# today. And so folks were afraid that if this .NET got popular, these apps would not run on Sun's Java. And so we also built a library called WebFC, and that was basically WinForms, except for Java. We had all these Java tools. But instead, Sun wasn't very happy with that version of Java, and so they sued us, as should be. And that's actually a point about .NET, which I'll mention later, that we will not sue you if you copy .NET. We actually put a statement out a few years ago when we first open sourced .NET Core that no matter what you do with it, we will not sue you. So if anybody in the room wants to just take the GitHub account, copy the whole thing, and call it your .NET, you are welcome to do that, and I will not sue you for it, because we are actually truly open source. Not some pseudo thing. But anyways, instead, in 2002, we released the .NET Framework. And so we replaced the Java language with C# and VB. All the features that we wanted to put into the Java JVM, we actually put into C#. And then, of course, all the apps run on top of Windows. And we have WinForms as the desktop framework, and we have ASP.NET Web Forms as the web programming feature that we put in there. So that's kind of how we got to .NET. We started off with Java tools, and we moved to the C# tools, which I'm glad we did, because I think they're better than Java. And this is one of the ones that Scott Hanselman and I like to talk about all the time. This was a weird phase of Microsoft. We released this thing, Microsoft plans shared source.net. So has anybody ever heard about this project? By hands. We released an open source version of .NET that contained no source code from .NET. This was Microsoft open source back in the day. It's like, hey, we'll just release some source code to something. And the idea was, hey, if you work for an education institution, college, you can have a version of .NET that doesn't run .NET code, but you can do whatever you want with it. So that was kind of a funny history of .NET. And the funny thing is that we're pretty successful. This slide is a couple years old, so the numbers are actually a little bit lower than they really are. But we have over 1.8 billion. I think it's actually 2 today. installs of .NET. We have 6 million developers using .NET every day, and it works on a ton of devices. So, as I said, I joined in 2007, and as I joined Scott Guthrie's org, and there was this phase, this shift inside of Microsoft, where we were moving away from the proprietary closed source to more open source. And so in 2008, we did open source one of our first frameworks, which was MVC 1.0. But once again, to make fun of ourselves, there's all these licenses, Apache. We didn't use any of the existing open source licenses, made our own. Because we're Microsoft. You can't use somebody else's open source license. You've got to make your own open source license. Now, the joke about that, even though I'm making fun of that, it actually is a really good license. It let you actually download and compile the code. You could distribute the source code. You could do whatever you wanted with it. It was actually a really good license, even though it wasn't necessary. But of course, we didn't take contributions. We'd already freaked the lawyers out enough just doing this, that the idea of saying we're going to take contributions was crazy. So then in 2012, we really open sourced ASP.NET and Entity Framework. And I'll tell you a funny story around that. I'm not sure if that was my customer or my lawyer. We open sourced this at a conference, and I was so paranoid that Microsoft Legal was going to come stop me before I open sourced it that I checked into my hotel in Las Vegas, and I put my cell phone in my room and turned it off, and did not have the cell phone. This is me and Scott Hanselman. We're together. We're gonna put the open source this thing on a stage, and so paranoid, we turn all our stuff off and put it away. So there's no way they can contact us and tell us not to do this. We're not going to check email anymore. We're not going to get stopped. And so I assume you probably know that Scott Guthrie is the executive vice president of a lot of Microsoft today. He's kind of the father of .NET. So we are actually in the hotel, and nobody can find us. We get paged by Scott Guthrie in the hotel. Never have I been at the MGM Grand and Scott Guthrie paging Scott Hunter and Scott Hanselman. Because he was actually going to be part of this open sourcing thing as well, and he couldn't find us because we turned all our stuff off. And we actually got on stage, and we had Miguel de Casa, who's now at Microsoft. He came out on stage, and we took the first pull request for these frameworks from him. So it's a happy part of .NET for me. So we open sourced these, and you can see that we put them on a real license, an Apache license this time. Same kind of rights, you can do whatever you want. And we took, for the first time ever, we took contributions. So we'd actually really kind of got into the open source world. Then I like to make fun of myself many times. At Microsoft, if you do something good, you put it all into everything. So if people go back in time and look, we actually called Windows Server in 2002 Windows Server.net. Now, the funny thing about Windows Server.net, it didn't include .NET. Somebody, maybe Scott, maybe marketing, I don't know, they thought that the best way to make .NET be successful was to put it on everything. So I remember being stunned. It's like, oh, Windows Server.net that you have to then go and download and install .NET on afterwards. Interesting. But we did like, once .NET Framework kind of got some success behind it, we made a lot of these things. .NET Compact, .NET Embedded, Silverlight, a whole bunch of different versions for phones, Universal Windows Platform. Then there's Mono, which we didn't create, but it's open source because we were closed source. There's way too many .NETs. And of course, since I was new to Microsoft, what do I have to do? The way to get promoted is to make another .NET. So I did make another .NET. This was .NET Core that we shipped a couple years ago. And I will tell you a funny story about that as well. Is we were in the process of actually building .NET Core, and there was a good reason in this case for building a new .NET, and that was we wanted it to be a little different than the older .NETs. And I once again was sitting in with Guthrie to get approval for this thing, and he tells all of us, he goes, "You got one shot. You can only make a new one every 20 years." So I should actually put that on a calendar somewhere that 20 years from now, we can make another one. But if you do a 20-year space, you will never have this problem again where you have all these, because it was a long time to make that many .NETs at a 20-year increment. Okay. And of course, this time, we really open sourced all of .NET Core. So all of .NET Core is fully open source. This slide's a little old, but it shows this slide I put together a couple years ago just because we were asking, how's .NET health? Is it healthy? Is it growing well? And you can see we have a ton of contributions. At this point, more than half of the contributions, half of the code in .NET comes from outside of .NET, which is awesome. We are super happy that the open source movement on .NET Core was so successful. And then it's funny when you think about who is actually putting code in .NET, and you see names you would never expect. Google, Samsung are ones you might not expect. Nokia, Siemens, a whole bunch of these. Samsung's actually a really cool one. They actually are responsible for the ARM port of .NET Core. Does anybody have a Samsung TV they bought this year? One person? If you bought a Samsung TV in 2018, you might not realize this, but the actual interface in your TV is actually .NET Core. So Samsung put .NET Core into all of their TVs, all of their devices, and it's the primary programming model. In fact, they took Xamarin Forms and ported it to their ARM version of .NET Core, and that's what's the actual interface for your TV is actually Xamarin Forms. And they did that because we don't sue you for using .NET. You'll see that Google has lots of fun with huge lawsuits from Oracle on using Java for Android. And we are hardcore. We're not going to sue you for using .NET. It's an open source platform. Do what you want with it. This is a funny one that this says about a year old again, but it shows we were the #1 most contributors in GitHub. It's kind of a funny one as well. It's got Microsoft Math in it. And when I say Microsoft Math, we have Angular and Google as separate line items. Last time I checked, Google makes Angular. So you should really add those two together. But still, to think we went from a closed source company to a huge open source company, and we have this many contributors on GitHub is an amazing achievement, I think. This was a fun one we did a while ago. I think Jeff Fritz is responsible for this. We were looking at where contributions to .NET Core were coming from. And this shows what it was in 2015. And this what it looked like in 2017. The open source thing really has worked. These are people that filed issues or bugs, suggestions, or actually code changes. So the open source movement has been really well received. And we'll go blah, 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 blah. Oh, okay. We're doing on time. So we'll go back to modern times now. This is something we've been chattering about for a while for .NET. We're very happy to say that .NET is way more than just the desktop and web that we started with. We have great support for cloud. We've got mobile with Xamarin. We just introduced at Build a bunch of IoT stuff. I've got an IoT thing on the stage here. And we have a new library we introduced at Build called ML.NET. So we're building AI and machine learning into .NET as well. So we're really trying to make sure that no matter what you want to build, .NET is a potential solution for you. This list last year shows that we added 1 million. Once again, some people come and go, hey, Java's popular, Node's popular, how are you doing? We added 1 million new developers, monthly active developers over the last year. We have over 500,000 multi-time per month users of .NET Core, 1 million single-day users of .NET Core. So both of these platforms are growing and growing very fast. And I kind of want to reset. One of the things that we always do when we do talks in .NET is we always talk about the newest thing. And I'm trying to stop doing that and kind of talk about what we've already shipped as well. So .NET Core 2.1 shipped a few months ago. And it had some pretty amazing improvements. So one of the things when we did .NET Core, we wanted to have a reason somebody to care about .NET Core. It's like when you start comparing .NET Core to Node or Java or Go, well, why is .NET better? And the thing we kind of picked on was performance. We wanted to be the fastest web framework out there. And you can see in the 2.1 wave, we went 15% faster on plain text. We went 18% faster on serving JSON. And we went 150% faster in serving SQL or any databases. And you might ask what that looks like. Let's go look. Download actually finished. Good. Not die today. So I'll go up here. Let's go look at Tech Empower. This is a benchmark that we don't run at Microsoft. Well, we do run it. We run it on our own hardware, but they run their benchmarks on their own hardware, and they publish their results. And the web's going to be so fast up here, nothing is going to appear. Browser's unhappy. Like the old BBS era. All text, no graphics. This is Tech Empower round 16. And let's find, where is round? Right there. Circle of patience. What you'll see in this benchmark is .NET is in the top 10 of almost every category. And some of the categories are so close together that it doesn't matter because they're all within a few thousand of each other. But .NET is leading in almost all these categories, and so we're super fast, and that's one of the big tenets that we have in .NET, and we will continue to focus on that. I'll let that try to load, and I will come back to it. 2.1, we introduced a bunch of major features. Biggest stuff being something called Global Tools, and I'll demo that. That allows you to actually install new things to .NET right from the command line. And we basically put this feature in for ourselves. It's a way for us to extend .NET without putting a bunch of junk into .NET naturally. So you can actually put command line tools into NuGet and just pull them down. Performance-wise, span of T, sockets, and HTTP client performance are all in the performance side. We rewrote our socket layer to be super fast. We rewrote the client as well. So HTTP client now is 10 times faster. Span of T is all about saving memory. A lot of times in programming, what you do is, like in the web, a header comes in. The first thing you do is take all those bytes and make a new .NET structure and copy all the bytes to it. And so you just duplicated all that memory. Span lets you actually take a bunch of memory and map it onto types without duplicating it. And so we use that feature inside of .NET to make our entire tech go faster. We created something called the Windows Compatibility Pack. This is a NuGet package. It makes .NET Core a lot more compatible with .NET Framework. EF Core, we added lazy loading. That's a feature from EF6 that we brought over. ASP.NET Core, support for HPS out of the box. We have Razor as a library. You can now take UI and make it into a NuGet package and share it across multiple applications. We built something called HTTP Client Factory. This is for building microservices. I'll do a demo of that. And we added SignalR to Core, to ASP.NET Core. So you'll see this continual thing of more compatibility, more performance, is kind of the gist that we're doing here. SignalR, SignalR is a framework for doing real-time in .NET. We've now actually got a service in Azure that just went live a few weeks ago. So if you want to run a SignalR backend, you can just put it in Azure and just drag sliders to the right as far as you want to scale up as much as you want. And it's pretty cheap. And I'll actually do a demo of that in a second. Okay, so let me show some .NET Core 2.1 to start with. And I'm going to show HTTP Client Factory. Close this out. And we will go to the retry app. So what I'm going to show is something that everybody should be doing. In fact, we should actually take some of the code that I have here and just put it in the freaking framework, because it should be. I've got a simple API. I mean, it's an amazing API. As Scott Hanselman would like to say, very much. This API is what you would actually, a manager would write. Good source code, folks. It'll run very fast. So let's take this, and we're set here, right? And what I'm going to do is I'm going to run this API, and it's not going to do what you expect. Go over here. Browse to this. And great. There you go. Isn't that amazing or what? I'm done. If I refresh this a couple times, oh, something happened there. And my favorite part here is the computer just says no. So what I did is we have this tech. I've got this thing that I've written here, and it says when the request starts with API, whack API, I'm going to inject some code I want to run. We call this middleware, and it's called random failure middleware. And so what it does is it just means that any API that I have on this machine will randomly fail. And you can see it's simple code. All this does is every request comes through here, and we say there's a 50% chance it's going to fail. And so, as I said, not a bad idea to just go stick this in your own code to see what happens to your app when you do this. So there's a point to this, and the point is if I go down to my, I've got a web app here, and in my web app, what I do is I go and when the page loads, it goes and grabs that URL from that API and writes the value to the screen. Because I know everybody does this. You have you got an app, your app's calling APIs, and you probably have no code to check for failures. So if I run this, exciting app comes in, and I run this a couple times. Oops. The computer says no, not good. So how would you fix this? Historically, the way you would fix this is you might write your own wrapper for returning a URL, or you might do something really stupid like while values equals null. I mean, let's do it. Somebody in this room has written this code before, I promise you. Let's put this up here, and let's do the worst thing you could ever possibly do. And let's just say catch. There you go. We're just going to beat the crap out of it until it works, and not even look at the result of this. This is not good code. So one of the features that we put into Core 2.1, and the reason I do this demo is because it's actually an amazing feature, is something called an HTTP client factory. And what it lets me do is I can come over to my services, and I can say services.add HTTP client. I can give it a name. And then I can set a bunch of rules on this client. So in this case, I might want to add a transit HTTP error policy, because this is one of the things where I make fun of my team again. That's a great name. Transient HTTP client error policy. But in here, I can do things like policy equals policy dot retry async, and I can say retry 10 times. And I'm doing a very simple version of this. I could actually put rules in here that says, try it. If it fails, wait 5 seconds, try it again. If it fails again, wait 10 seconds, try it one more time, and then fail. But the cool thing is I can build all these rules in one place. I can have different sets of these rules, and I can name them. I name this one API. So I can go and I've got this new client. Now, over here in my code, I shouldn't just new up an HTTP client now. What I would do here is I'm going to put an attribute that says from services, HTTP client factory, and I'm doing this because that startup.cs, when I added that, I basically added that API to dependency injection, which means now that can be injected into any controller or any method in your any class in your app. And so what I'm saying here is I know that's going to be injected. So in my kind of constructor for my page, get the client factory from that DI. Now I can come back here and I can just say factory dot create client API. So instead of actually putting retry logic all throughout all my pages, now I can set it one place in my application and use it everywhere. I can go change that. I could change that retry policy in that one place. It affects my entire application. And if I didn't do manager typing, this page will not error anymore because that retry policy is there. So I introduced a purposeful failure in my app. Test if my client could actually recover from that. Now I've got a client that recovers from that. That's HTTP Client Factory. So one of my favorite features, and I hope this demo makes it simple enough to see because it's challenging to show that demo. We'll go back here and look at this. Here's the performance stuff. Look at this plain text. Everybody is in the 99 percentile, including us. So, and you also find here you don't see Java or Node or any of those types of things. A lot of things that are here because they just make crazy frameworks just to beat the benchmark. Fortunes. This is one that does database access. So this is a real web app. It's not just a simple call an API. The ASP.NET Core is number 7. We're all not in the 99 percentile, but we're still faster than a lot of tech. You're not going to see your Javas or your Nodes or stuff up here. And so real workloads, benchmark workloads, we kick butt. Okay. Go back here. .NET Core 2.2. This is something we plan to ship later this year, probably in the November-ish timeframe. There's a preview 2 out today that you can grab. We shipped a few weeks ago. You can grab that if you want. .NET Core is side by side. You can install a lot of these on the machine and not break any of your apps. So it's actually safe to go grab previews. Big thing you're going to hear from us, this is kind of our themes moving forward, is we want to make API development much better. Pretty much everybody has APIs, whether you're building an Angular or a React app, you need to call some API on the back end. If you have a mobile app, you need to call an API on the back end. If you want to make your app accessible to other people, you want an API. The next thing is we're in the microservice era. Just like you put .NET on anything back in 2002, now you have to say microservice on everything or you're not cool. And so we're going to say microservice with .NET because it's cool. But that said, some of the stuff I just showed you, HTTP Client Factory was kind of a thing we put in for microservices. Break your app into APIs. We want to make it where .NET's awesome at calling those APIs and writing those APIs, and you're going to see continued performance. So here's a pile of features that we have coming in the 2.2 wave that I picked out that I thought were cool. Multi-tier JIT. This is something where Java's had this for a while. We've added it to .NET. And what it means is when our jitter runs the first time to turn your code into executable instructions, we use a fast jitter because we want your app to start fast and run fast. But what'll happen now is if you keep hitting that same code, we'll detect that and go, we should use a better jitter. And so we'll re-jit it at some point and make it faster. So that's what multi-tier JIT is. EF Core, we've always had support for relational databases like SQL Server in EF Core, but we want to go start looking at NoSQL databases. So in this case, Cosmos DB, which is one of the databases we have in Azure, we now have a provider for EF Core, so you can actually talk to a NoSQL database. And in many cases, depending on what your workload is, if it's just to shove data in as fast as possible, a NoSQL database is actually faster than a relational database. A lot of us, my background, I always did relational databases, and it was hard for me to break out of the mask of everything has to have relations and stuff like that, but core boards and stuff like that really fit here well. We've added support for geometric types, so longitude, latitude in here. ASP.NET Core gets a ton of stuff. Latest Bootstrap and Angular versions are supported now. A bunch of Web API improvements, and the biggest one, which I'm not going to demo because it'll come in Preview 3, is API security. One of the biggest questions people always ask me is how do I, in an MVC application, I can put an authorized attribute on controllers and stuff to lock them down. How do you do that in an API? For the first time ever, we have that in the box. HTTP 2 support is in here as well. And once again, on that microservice standpoint, we have something called health checks. And health checks is something where you can write an API, and that API can actually have a series of tests that can be run on it. And what you would do is, in the container world, you get into these things like Azure Kubernetes Service, the container orchestrator can call these health checks to see if the API is actually safe. And if it's not, it'll not send any request to that particular instance, maybe a different instance. So a lot of cool stuff we're doing in this space. And so let's do a demo in .NET Core 2.2. Close this one out. And we will launch this. So I mentioned, thank you very much. It'll still work. So this is, I mentioned something called global tools earlier. And global tools, I can do .NET, tool, list. I make fun of my team here. This is garbage. I'm going to run this. First off, I'm red colorblind, so that's a bad thing. Please specify either a global option, -global, or the tool path option, -tool path. 99% of the time, I want that, but I have to type -G every single time. Great. But you're going to see I have a tool here that's installed, and you might ask, how do these things work? -G. And I had Hanselman actually text me this awesome global tool, NYAN cat. Maybe you've seen this before. I know that I've created an awesome ecosystem with .NET when I see tools like this exist. I recommend everybody install this as soon as possible. And the internet's going to not make us happy. Wait for that to install. But what I want to show you is I've installed a global tool called .NET-HTTP REPL. And the whole idea of global tools is it gives you the ability to build your own tools that can run on any machine. They'll run on Windows, Mac, Linux. They can be installed right from the command line when you have internet. And you can run them. And so we, as the .NET team, will use this to go add stuff to .NET without actually having to shove it in the box. I don't want to take everything that we kind of experiment with and play with, like this .NET HTTP REPL. That shouldn't be part of .NET. These should be, if you're not building APIs, you don't need this. I don't want to keep filling .NET with stuff. Our goal is not to have 7 GB .NET. We want to have small .NET. So what I've got here is I've got a API project. And what I've done is if I go to my browser, I can go and say browse with. This is how you select which browsers you have. And you're going to notice that I have one of these called HTTP REPL. And it actually points to that global tool that I have there. That is impressive. That is so amazing that I will try something real quick. If the TechBash is actually better than the TechBash for the win. So for fun, you're going to notice I have an Explorer window open up. You might ask how global tools actually work. So under my username, there's a .NET folder, and there's a tools folder underneath that, and we put this on your path. And so when I ran that command, it stuck that over there on the path for me. So it actually went and grabbed the .NET code, downloaded it, out of a NuGet package, stuck it over there, and now I can do amazing things. I can type. Hold on. .NET for the win, guys. You can do this in .NET. Scott Hanselman showed me this, and I just had to. But what's cool, just to show this, I could actually do uninstall -G, and you'll watch the it disappeared under the Explorer over there. So this is the ability to take .NET code, bring it down, stick it in a global path. It makes it easy to build tools, and we're building our own tools. The HTTP REPL. I can go back here, and you see I've got the REPL that I've added as a browser. And this came out of a discussion that happened last year in my team. We were sitting in a room, and I'm running an API app, and I'm like, Chrome. And I'm giving my team a bunch of crap because it's a great debugging experience. Nothing can be found because an API app doesn't have any UI. So Visual Studio is primarily great at building UI. It doesn't have great debugging for non-UI kind of platforms. So we say we have to fix that. So first off, this app is a little goofy. I've added under NuGet packages. You're going to see that I've got something called InSwag. This adds Swagger to an API, and we will have a microservice template in the 2.2 or 2.3 time frame that will give you an API project with Swagger and all the stuff built into it, so you can do what I'm going to show next. So I'll change my browser, be that REPL, and now when I run the application, first thing you're going to see is it says using Swagger metadata from this URL. Let's go grab that URL, see what happens here. And so you're going to see a bunch of metadata here from my application. And you'll see at some point there's a people get all, people post, people get, values get all, values post, values get. So what this is this takes the API that you've written with ASP.NET Core and produces a bunch of metadata. Now the cool thing with that metadata, I can do things like here I can say dir, and you're going to see it's going to give me, hey, there's a people get. I can say get people. And so now I can actually call the API right from this command prompt. I can even CD into that. Once I'm in people, I can now just do get. So we kind of give you the ability to browse around and try your API. But we're not perfect. I can do post. Gives me this nice window. I can put an ID in here, and I could say I'm TechBash. Awesome. Save this. And it will fail with unsupported media type. So the reason it failed, this is where I like to make fun of my team. I have this notepad file here just so I can work around this particular issue. We live in a world of JSON. The developer working on this decided we should not set JSON as the default. Because you might want to have to specify that every single time you use the product. So I can do a post, and I can paste all that junk I just copied there, which is dash header content type application JSON. This will be fixed before we RTM, folks. That developer, no, I don't know. That's why we have PMs at Microsoft, is to make sure this does not happen. I get a success this time. Now I can run the get, and there's TechBash added. So I can easily call my APIs. I could set breakpoints in my application as I call them. We give you a great thing, And of course, we know you love UI, and so there's also a UI for the UI folks in the room. So come over here, do your get people, try it out. Notice it defaulted to what? Just saying. I love this as being streamed because my engineering team will watch this at some point and I'll get in trouble. So it's amazing. And so that's what we're trying to do in the 2.2 wave to make APIs easier to use and work with. We'll give you this great debugging experience for APIs. We'll put the Swagger in for you automatically. And the cool thing is we're able to extend .NET using those global tools. So I don't have to go and just put a bunch of junk into your project or into .NET. I can say the first time you try to debug an API, we go and install that tool. And if anytime you want to take it off, you take it off. So that is that. Let's go back to the slides. And we'll talk about .NET Core 3. So we introduced, first off, I will tell you, the .NET Core stuff is interesting. Damian Edwards and I sat in a room. He's one of the leads on my team. And we're building .NET Core 1.0, and we're like, yeah, we think we'll have a new version about every 3 or 4 years. We don't need to go that fast. Here I am 3 years later, and I'm on .NET Core 3. And so there's a reason for that, though. We've been moving fast because we shipped .NET Core 1. Our real goal was to have an open source cross-platform version of .NET. We had some customers that really needed Linux. And so we rushed to get a version of .NET Core that would run on Linux for people that were running containers and microservices. But we got a lot of feedback. It wasn't very compatible. It was not. We had a very small set of APIs. .NET Core 2 brought a ton of APIs for it. And then .NET Core 2 also did something else. We created something called .NET Standard. And .NET Standard is all about, I want to be able to share code across all my .NETs, whether it's a Xamarin app, a .NET Framework app, or a Core app, easily share code. .NET Core 3 is the next wave of this, and the primary focus on it is desktop development. We have a variety of people that still build desktops. I know it's crazy. If I told you the actual numbers, it would melt your minds. It's in the millions. They're building desktop applications in .NET today. And they're not feeling loved because they're not in the .NET Core world. And so we're bringing WinForms and WPF to .NET Core. I want to be very clear, though, just because .NET Core is cross-platform, WinForms and WPF are not cross-platform. They are Windows technologies. People always ask me, hey, you're going to port WinForms to Linux. No, that's hard. And well, WinForms is technically a wrapper around HWind, which is a Win32 concept. And Linux doesn't have an HWind, so you have to make up your own thing. WPF is built on DirectX. And so unless you have a DirectX that runs on all the other platforms, it doesn't really work. And if you had WinForms and WPF apps that actually ran on a Mac or a Linux device, they would still look like Windows apps, so they would look weird. So you don't really want it, even though you think you want it. We might do a cross-platform UI thing in the long run, but it would be something different than these. But this is really saying, hey, I'm a WinForm WPF customer, and I want to take advantage of all the new stuff in Core. Can I do that? And so, we are adding desktop, IoT, and AI. I said that in my first slide to this. Here's a couple reasons why people might care. So there's a whole bunch of desktop improvements coming in the next version of Windows, the spring version that will come out next year. First of this is going to be XAML Islands. And this is going to let you, we created something called UWP a few years ago. And it was another framework for building desktop applications. It has a problem, though. If you have a WinForm app or a WPF app, you just can't move to UWP. You have to rewrite your app from scratch. I don't want to do that. So XAML Islands will let you take your existing, the new controls that have been introduced in UWP, and you can put them into your WinForm or WPF apps. So it's kind of like we had something in the ASP.NET team called One ASP.NET, where you could use web forms and MVC and SignalR, Web API, all in the same project. This is the same thing. You can use all the Windows techs all in any project. If you have a WPF app and you want to add touch to it, grab a UWP control, stick it in, you're good to go. Biggest thing here that a lot of folks care about, if you use a browser control or a media control in a WinForm WPF app today, they actually use Internet Explorer, kind of old, and they use Windows Media Player. You'll get brand new browser media controls that can play in all the latest formats. There's another thing I showed at Build called the .NET Core App Bundler. This is the ability to take a core app and make a single exe out of it. The single exe contains the framework and your app, which means nothing has to be installed on the machine at all. I can take a memory stick with a WinForm app, give it to anybody in the room that has nothing installed on their machine, and it would just work. That's something we're working on. Why? If you're a .NET Framework developer, why do you care about this? Core is side by side. We can actually go faster than we can go with .NET Framework. We're still updating .NET Framework. It's not going anywhere. But the reality is, to keep it compatible across those billions of machines, I can't just go change it a whole bunch. .NET Core has a side-by-side compatibility feature in it where you can have as many on the machine as you want. And so this allows you to take advantage of the newest APIs without having to worry about breaking other apps on the machine. You get access to some of the new core runtime and API improvements. Once again, as I said, with .NET Framework, I can't change like the file libraries. You know, if you want to access the file system, if I change those, I might break an app, one of those 2 billion apps. It's not because I want to. A lot of apps take dependencies on the behaviors of some of our bugs. If I fix a bug, I might break something. So there's reasons that people might want to try this. And so the updates is, I hope to have a public preview out, I would hope in December, of this tech. But we have made a lot of progress since Build, and I want to show that progress. So I can come back to VS. And this is a demo I showed at Build, and I want to show it before I build demos. This is a fun demo that we put together at Build, and the cool thing was, you might have thought, hey, it's a fake demo. It was actually really real. And what it is, it's an app that we have both a .NET Framework version, and we have a core version. I'm going to run the .NET Framework version. It's a fancy app. You put it in a folder. You run it. Gives you a nice pie chart. And you can click the pie chart to see what that was. And I got this question mark button here. You can load, and it shows you what DLLs it loaded. So you can tell this is definitely .NET Framework. Loaded there. That's kind of cool. Then we showed that there's I can build a core version of the exact same application. And the point we're trying to make on the core version was I can edit my CS proj. And you can see that even though Telerik has never seen .NET Core with desktop, I was just able to add their DLLs. It just works. It's compatible. That's what it should be. And so I can run this app. It's going to be exciting. It's the same app again. But it's a little different. Let's go run it. This. And the big thing I want to call here is it does the same stuff. And I can click this button, and you can see it literally is using that is .NET Core, the DLLs it's got loaded. So it's definitely loading the .NET Core DLLs. But if I bring these two up together, I want you to notice something. A lot faster. And that's because we actually changed the file APIs in .NET Core. We've optimized them in a way that I can't optimize them in .NET Framework without breaking compatibility. We made another change here as well. Once again, this is, you bake behavior into your framework, and you can't change it. The core one will not blow up if there's hidden directories. The framework one will. And so we can't change that behavior, because if your full framework app started pulling folders it couldn't pull before, that would be weird. So we can make small, subtle changes in .NET Core. You'll see, so you take your WinForm app, your WPF app, move it to Core, it's going to run faster. Because we have improvements in the APIs that we can't move into the full framework. So I'll do one more quick demo in the desktop stuff here. I just got a folder here, and I'm just going to do make dir, well, just .NET new WinForm dash out I want to show the progress we've made since build. Build, an engineer and I sat in a room and we made that other demo, and it was probably really hard to recreate. But now I just did .NET New. I can go to the WinForm folder, .NET Run. This is just using the internal nightly builds of .NET Core. And you can see now you can basically create a new .NET Core WinForm application right there. I could do .NET New SLN, .NET SLN add. What I did is I just created from command line, because we don't have this in VS yet, I created a solution file, and I added the csproj to the solution file. And then from that, I can come over here, go to my source, port 3, WinForms. I can open it up in Visual Studio. We don't have designer support in VS for this yet, but I just wanted to prove that even though that I showed it from command line because I don't have a file new in VS yet, you can run and edit these things inside of VS just fine. I could do the classic writing my first WinForm application. WinForms actually kicks butt. It is amazing how simple it is to use. Boom, hello TechBash. I'll show one more real quick. We have WPF up as well. I can do .NET New WPF -out WPF. This one's not as far along as the other one. And so if you're not up on thank you, Windows. This one requires some kind of voodoo. I've got to go and open a developer command prompt, go back to my source, at Core 3, WPF. Now I need to actually run MS build to compile this thing. Get piles of errors. It looks really healthy. But if I go into my bin folder, I made this complicated as well. I can actually take the DLL that was produced by that, .NET WPF.dll. And while that's complicated and confusing, the point is we're making progress. We're getting closer to a preview. That's a WPF app running on .NET Core. So those frameworks are getting close to being in the real world. Now, let's move on and show probably my favorite thing. Some people laughed. I hope it's because you like the tech. One of the guys in our team, people sometimes ask, how do you come up with stuff like this? So Blazor is a interesting project. I'm not a fan of JavaScript. If you like JavaScript, good for you. I'm not trying to convert anybody. But Blazor was a demo that Steve Sanderson on our team built at NDC last year in 3 days. He's terribly smart. And he thought it'd be a cool technology demo. And then we found out about it, and we're like, we want to do something here. So Blazor. And we're going to remove the experimental title from Blazor. What it does is it lets you write .NET code that runs in the browser. So today, if you're building a web app, you're probably using Angular, React, Vue, one of those common frameworks. Every 6 months, you're on the next version of that framework. Whether you're on version 6, we went from 1 to 6 in 2 years. So I don't feel bad about being on 3 in 3 years when they're on 6 in 2 years. But those things are changing all the time. And so one of the cool things about having .NET code run in the client is you don't have to use those frameworks. And .NET has been around for a long time. It's very stable and consistent. Same tools have existed for years to run it. This stuff runs in all browsers. You get native performance. You get full .NET performance in a browser. Strongly typed. You can share types from the server to the client. No plugins. Plugins are being banned by browsers. This does not require a plugin, and it literally works in all browsers, whether it's on a smartphone, a tablet, whatever. You can share C# code across both of these things. Let's go load the Blazor app up. Here. Has everybody in the room already seen Blazor? Some. Okay. This is your typical app. This is how you would write this today. I've got an image here on my page, and I've got some JavaScript. And my JavaScript is stuck over here. And you're going to see what it does is it finds that image. It looks at the URL. And if there's a 1 in it, it changes it to a 2. If there's not a 1 in it, it changes. If there's a 2 in it, it changes it to a 1. So this gives you that awesome, modern web. Not run it that way, please. Modern web experience using JavaScript. It does what you would expect. I click him, and my URL changes, but my page doesn't refresh. I get that desktop feel in my browser because I'm using JavaScript. So what would that look like if you rewrote that in C#? So let's do that. So the first thing is, this code needs to go away. Gone. Let's go to my index page. And let's do something different here. Let's go and do an @functions. This is how you can write some C# in a page. And inside of this function block, I can write my C#. So let's create a string image URL. We'll just steal that code right from here. Grab that. Move this down into that. Awesome. And so I'll replace that. Now I don't need to have that be in there. I'll just grab that and say @image URL. IntelliSense works. Good to go. Great. Now let's change that on click. I need to create a .NET version of that on click. So let's just say change image. And we'll just do the .NET version of this. We'll say, hey, if image URL, I can type, contains, if there's a 1 in there, write some code, else we'll write some other code, and I would probably do something like image URL equals image URL dot replace. We'll replace the 1 with the 2. Then, of course, I would come down here and I would do the opposite down here. With the 1. And does that look okay? It does. Okay. So now I would change that JavaScript with the @ sign to go into .NET mode. And for consistency purposes, make you remove that. Amazing. And let's compile that. So what I've done is I've taken all the JavaScript out of the application, and I've rewritten that in C#. And let's go see what the result of that looks like after the build hang. I will warn folks that I am actually using, my machine has all kinds of crazy bits on it. So stuff happens. Good. Okay, so it's building, and a bunch of weird stuff's going to happen. You're going to see a bunch of stuff scroll, and I'll show that in a second what just happened. Let's launch the browser. So here we are, same app, same behavior. Notice it's not doing a callback, a postback, or anything like that. So my .NET code is actually running in the browser. You might say, I don't believe you. Here, if I refresh the page, bunch of weird stuff's going to happen over here. MS Core Lib, Net Standard DLL, System Core DLL. .NET just came down from the client, from the server to the client, and we're actually running natively in the browser. And so this will allow you to basically write .NET on the client, on the server. It just works. It's super fast, and it's friggin' amazing. And maybe you still don't believe me. You're like, yeah, you faked that. Let's try something even crazier, which sometimes works and sometimes doesn't work. I am trying to launch the Chrome bugger on this application. The first thing it says is you can't do that because you have to go and tell Chrome that it's allowed to do remote debugging on a URL. So what it says is I need to close all Chrome out and run this. That. Chrome's gone. Run that. It relaunches Chrome. Now, I should be able works. Okay. Over here, sources. Move this around so you guys can see this. And you can see the Blazor client DLL shows up in here. I can click the Blazor client DLL. I can go to that index page. And if I scroll down, what source code do you see? .NET. Now, would it be crazy if I could put a breakpoint in the .NET code? Don't do it. Let's click the button. Paused in debugger. I am now, is this cool or what? Stepping through C# in Chrome. What'd you say? I don't know how to explain it, actually. So what we did is we, as I said before, we're using a technology called WebAssembly. And WebAssembly allows us to, WebAssembly is a spec that all the modern browsers support for running native code in a browser. And it's cool because browsers are actually sandboxes, meaning that they're secure environments to run code in. So it's not like we were installing ActiveX controls of the old days, where you installed COM objects and stuff like that that had global access to your machine. This stuff only runs inside the frame of the browser. It can't touch anything outside the browser. So and other tech is using it as well. You can run Go in the browser. You can run Java in the browser using this technique without using plugins. So we're running .NET in the browser using that technology. The debugger that I just showed works because we've actually implemented in part of our code support for the Chrome debugger extensions. And so we listen on the ports they expect us to be on, and we can do source mapping and stuff like that so you can actually make this experience work. This experience is not perfect today. The debugger can't do everything you could do in a debugger in VS. But I'm just trying to show where we want to go. We want to go to this place. And the thing is, when you're running .NET in the client this way, we'll give you native performance. So you're not running through a JavaScript interpreter or something like that. You get native .NET on both the client and the server. So it's pretty cool tech, I think. That was actually amazing. It worked. So that's debugging with. So I'll show one more quick demo on the Blazor stuff. Maybe I can. How are we doing on time? 15 minutes left. I'll show one more thing here. So one of the cool things in the Blazor world is I've also got this counter here. I can click this. It's fancy. You click the button, the number goes up. The technology we're using behind this, we're calling this Razor components. And so what I can do is that other page, every one of my pages is technically a control. So here is the counter CSHTML file that was actually doing that click button. What's cool is I can go back to my index page where I've got my robot, and I could come here and I could say this. Let's do a BR, make some space, and counter. That page shows up as a component. And so now I put a counter in my index page. I run it again. Hit. Right hit was not what I wanted. Here. Let's run this. I said sometimes in this machine the builds will hang a little bit. So my hung state. Cancel that, give it a chance to cancel, and I'll try again here. So I added that component to the app on the index page. And once I do that, if I run it, you'll now see that I've got that same counter clicker thing on my main page. We make it very easy to build UI and share the UI across different pages. I can customize that even further, though. I could go to that counter, and maybe I want to do something like prop increment by, and I default that equal to 1. And what I can do then, I want to tell the web tech that's actually a parameter you can set. So I'll put an attribute on that calling that parameter. And then I'll change the code down here. Instead of doing a plus plus, do a plus equal increment by. So as I said, that's actually a control. I can add properties to that control. I can reuse that control elsewhere in my application, anywhere I want. Do my double build thing. In here. And by doing that, I can go back to my index page. And now, the IntelliSense says increment by, shows up now as a parameter. And I could say increment by equals 5. Save that. Good. Run the application. Now the counter on this page goes up by 5. The counter on this page goes up by 1. So make it very easy to build UI, share the UI. There's a whole bunch of crazy stuff you can do with this tech. And what our plans are is I just showed the version that runs in WebAssembly. We also have a version of the exact same tech that runs on the server side. You get this exact programming model. It works exactly the same, but we don't do the WebAssembly thing. The WebAssembly stuff is going to require us to do a little bit more work. To get .NET fully in the client is going to take us a little bit more time. We don't want to make people wait for this. So in the .NET Core 3 timeframe, you're going to get the exact programming experience, client-side performance, or client behavior, all in ASP.NET Core in .NET Core 3. And as I said, once we get to a little bit beyond that, we'll actually enable the WebAssembly part as an RTM piece as well, I think. So that's Blazor. It's one of the coolest techs we've built in a while. Enjoy it, try it. Machine learning in .NET, I'm not going to not do a demo of this. This is something we've added to .NET at Build. We announced ML.NET. And ML.NET is a library that was based on an internal machine learning library that we use at Microsoft. And we use that tech, the ML.NET, the tech behind ML.NET is used on Bing, it's used in Office, it's used in Visual Studio, it's used everywhere. And we said, hey, we have this great ML library built into .NET, why not give it to all of you guys? And so at Build, we open source that tech, we put it into GitHub, and the primary thing here is it gives you the ability to take data that you have, you can train and make a model, and you can run that model all in .NET. A demo I used at Build is We have a lot of GitHub accounts, a lot of GitHub repos. People file issues in those repos. They don't actually put the issues in the right places all the time. So we wrote a classifier that will actually move a GitHub issue to the right repo, the right place automatically. And the reason we were able to do that, we have our developers sit in GitHub all the time and properly move things around. So we have 3,000 of those we could go look at as data, pump it into ml.net, and then when a new issue comes in, we can run a tool that will basically go say, that belongs over here by looking at the issue. And it's accurate to about 99.9%. And so this is an example. I don't have a demo today on this, but this is tech that's coming. We're currently on 0.5. I hope to RTM this next year. It's quite usable today. The primary reason it's a 0.5 is this tech was built by a bunch of ML people, machine learning people. And they're not you or me. And right before build, I'm sitting with my team, and they showed me this demo, and I said, show me the source code. I want to show the customers the source code at build. And I'm like, what is that? It was so complicated. And so what we're doing is we have people like Emo and Ankit on my team in Redmond who are just trying to make the APIs around the ML stuff human consumable. Because that's what we try to do with .NET. Our goal with .NET is to make hard tech like machine learning and stuff easily accessible to everybody. And so it's a 0.5 because that's what we're working on. We also want to build a UI tool around it as well, where you can point it at some of your data. It'll build a model, and you don't even have to write the code. So that's ml.net. I have 9 minutes left. And what should I demo? Let's try one thing real quick. Go back to my portable Wi-Fi spot. What I do is I have a travel router, which allows me to create my own network on the stage. Works. Now we'll demo something else. And I use it because I also have a Raspberry Pi on stage. And one of the things that we are really pushing for in .NET as well, I called it slides earlier, is IoT, Internet of Things. And we have IoT support inside of Azure. We have something called Azure IoT. Azure IoT is actually built on .NET Core. And so we've got flavors of .NET that run on these devices. Let's see how successful we can be. Might not work at all. Looking like it's not happy. It took too long to connect to the hotspot in the first place. Let's see. Admin page shows up. Cool thing is, even though I'm going to show you all this, you can't. Nice. Wow, my watch is actually on. Oh, it did come up. And so now I'm actually on a Raspberry Pi, if this ever seems to be unhappy. What I can do is I can actually jump into the Raspberry Pi, and you can install the entire .NET SDK on the Raspberry Pi and other IoT devices. I can do .NET New Console, .NET New Web. I can do .NET Run, all on this device. So .NET is leaving the ability to just stay on the desktops. We can now go to super small devices. There we go. Really going to be slow for everything that I type. Make dir test 3. Super slow. It's not .NET though. I'll just let that go because I don't want to hang on that. I'll show one more demo. Actually, no. I'll just open up to questions. So I'm not going to try to rush another demo in. First off, I'd like to say thank you for coming out to TechBash. Thanks for being a great host for me. I hope you enjoy what we're doing with .NET, with .NET Framework, .NET Core 1, 2, 3. And I'd love to open up and take a few questions from the audience if you have questions. Anything you saw today? Yes, sir. That's correct. The question was, with Blazor, because it's not interpreted by the browser, like HTML is interpreted by the browsers, HTML might look different on particular browsers. No, you don't have any of those types of problems because it's just .NET code, and it's running the same .NET code whether you're Chrome, Edge, Firefox, Safari. You should get exact consistent behavior across all those browsers. The markup is where you might get different behavior, but we just run native code on the. Come on, some brave people. Yes? So the question is, are we going to remove the core from .NET Core, or will .NET Core and .NET Framework merge into the same thing? And the answer to that would be, I don't see how we could ever get there. The big challenge we have is .NET Framework is installed on billions of machines. Windows itself depends on .NET Framework to be on the machine. For example, when you open up the IS Control Manager, a lot of the networking stuff inside of the OS uses that .NET Framework. And so if I took it off the machine or I changed to something else, that machine would not be the same machine anymore. So that's not something we could ever touch. So I think it's, the full framework is going to always be on Windows. And that's a good thing, by the way. You can always depend on that being there. I don't see any path to change that. .NET Core is fundamentally different than .NET Framework, as I was saying before, because it's side by side. I mean, if I go to this machine, where is it? You can see I've got a whole pile of versions of .NET Core on my machine. I've got a 3.0. The tech that lets us do that, it would be too hard to go put that into .NET Framework as well. .NET Framework's bigger than .NET Core. If I had side-by-side .NET Frameworks, imagine gigs and gigs and gigs of .NET on the machine. So I don't see a path to this. I think what we're going to say is .NET Framework is a great place to develop applications. There's no rush to move off of it. We're going to continue to add features to it. I showed that in the XAML Islands and stuff like that. But .NET Core, because of this side-by-side nature, will just move faster. And so I think they'll both coexist for forever. I don't think .NET Framework will ever come off the machine. And that's by design in a lot of ways. But .NET Core is our ability to change .NET at a faster pace. There's .NET Framework, which will move a little slower. And there's .NET Core, which can move very, very fast because of the nature of how it's put together. That answers your question, I hope. That's. Any more? There's a hand here. I don't know. The question is, when I talked about WinForms and WPF, I did talk about cross-platform UI, because the first people that goes, oh, you have WinForms and WPF on Core, it must run on Mac and Linux. What we know is we have a lot of customers that ask for cross-platform UI. It's something we are actively looking at beyond the .NET Core 3 timeframe. But it's a hard problem. The reality is nobody's done cross-platform UI good. Java tried to do it with Swing years ago. Google's got a project today called Flutter that tries to do it. None of them have really taken off, and I think the problem is most of us, if you're on an iOS device, you want it to look like iOS. If you're on Android, you want it to look like Android. If you're on Windows, you want it to look like Windows. Nobody's built good cross-platform tech that does that, but we are looking in the space. I mean, I will say we're actively investigating what we could do there. It would probably be more UWP-ish than it would be WinForm or WPF-ish, because those things are really tied to specific Windows tech. It could even be Blazor. It could be, imagine if you could host a XAML control inside of Blazor, and then it ran in the browser. There's a lot of ways to do this. I don't have the answer today, but we will look at it. Yes, sir, back in the back. Yes. Yes. That's a great question. So there was a blog post on Medium about 2 weeks ago written by somebody that said that .NET Framework 4.8 would be the last version of .NET Framework. I thought I addressed that earlier in the talk when I said there will be no last version of .NET Framework. In .NET Framework 4.8, we're adding XAML Island support, but .NET Framework, it's already been slow updating in the last couple of years. Meaning we mainly fix bugs. We make sure .NET Framework has access to the newest security protocols, the newest network protocols, and we will always continue to do that. I also should be very clear, lots of big services and lots of big tech at Microsoft run on .NET Framework, and they're too big and too hard to move off of .NET Framework. So even inside of Microsoft, nobody should be worried about support of .NET Framework. It's not going to go anywhere. It will always be part of Windows. We will always support it, and we will always add new stuff to it. But to remain compatible and not break apps on all those machines, we just can't change it the same way we can change core. And so core will go faster, and .NET Framework will go slower, but they will both continue to be supported. They'll both continue to be updated for as long as .NET exists. I think I'm out of time, so thank you guys very much for coming out, and thanks for having me.
All right. Test. Is this thing on? Hey, big thanks to Scott Hunter from Microsoft for coming out. We're having an awesome day here at TechBash in the Poconos of Pennsylvania. For those of you on the stream, we are live. We have some great content coming up today on the stream here in this room. Up next is Jeff Fritz talking about .NET Framework tips and tricks. And then after that, we've got Paul Yucknowitz doing a talk about 5 Azure services every dev should know. We've also got Richard Taylor coming up to do some unit tests. We've got other content all through the day. Guys, for those of you that are, we're running a few minutes behind, but don't panic. We'll straighten out the schedule. And again, big thanks to Scott Hunter. Thank you very much.
Thank you, guys. We're behind? We're behind? I apologize. You said 90 minutes.